Welcome back. We are continuing. This is the last leg of our problem solving, the third question. Remember, we've got only 4 cells. Hopefully, we have done justice to this section in terms of problem solving. The question is number 9. Again, simplified electrolytic cell below is used to electroplate a metal spring. Zinc nitrate is used as an electrolyte, and R is an electrode. Remember, we're electroplating here. If we are electroplating, we are covering another metal with the other one. So the metal with us where now we'll be covering. According to this one, obviously, if the electrolyte is zinc nitrate, hopefully, before we can even answer the question, we know that R, electrode R must be zinc. No problem. Then let's go to the questions. 9.1, they are saying to us, define the term electrolytic cell. Remember, we're defining electrolysis as a process, but now we'll be defining a cell. So you just tell the examiner that now, according to the knowledge that I've gained, this one is a cell that converts electrical energy into chemical energy. That is the electrolytic cell. We go to the second question, that is 9.2. Which electrode, R or metal spring, is the anode? Remember, anyway we know the metal spring, that's where we are going to be layering that spring with the silver, and therefore R must be the anode, because where there's a layering, there will be an increase in mass, it's the cathode. Therefore, it will be, according to our knowledge, it will be R. And now they say give reason for your answer. We know anode is where oxidation takes place. Just tell the examiner that oxidation takes place. You'll get full marks there. Now, the next one. Write down the equation for the half reaction occurring at the metal spring. That's where the layering is going to take place. That's where the zinc is needed now. Therefore, the reaction of forming zinc, if we go to the table, we'll find that now zinc is formed when zinc ions are reduced to form the metal zinc. That's the equation that will be now copying from the formula sheet. The reduction, we've copied the forward reaction. Forward will say zinc ions plus 2 electrons forms the zinc metal. Fine. 9.4. Let's 9.3.1 and 9.3.2. Sorry for that. Write down the name or formula of the suitable metal that can be used at electrode R. Said obviously, if you are covering the spring with the zinc, then R must be the zinc metal. Fine, no problem. Then R 9.3.2 would be Zn. If you write the formula or if you write the name, it will be zinc. Fine, but don't write or in the exam. You just write one of the two. No problem. Then the next one, which is the last one, is 9.4. 9.4, they are saying, can you explain the answer that we have given in 9.3.2? Why do we say zinc is the one that is at R in this case? So, because the electroplating is taking place, then obviously we say, okay, fine, the R is a anode. That's where oxidation takes place. That's where zinc will be oxidized in this case. So the metal that is the metal spring will be electroplated with zinc. So therefore zinc should be oxidized at the anode, as we have already said in 9.2. So metal spring. That will be the explanation. The metal spring is electroplated with zinc. Therefore, zinc will be oxidized at R. You can even include the equation according to this one of Zn forming zinc ions plus 2 electrons. Remember, in this cell we say the rate of oxidation at the anode equals to the rate of reduction at the cathode. So this is the reduction at the cathode, this is the oxidation at the anode. I hope now it's getting clearer. In when we are electroplating, yes, the rate of oxidation at the anode equals the rate of reduction at the cathode, and the concentration of the electrolyte remains the same. I think with those notes and those questions, you are a better learner now. You can answer any questions that comes in the exam. Hopefully you have done justice in this section. Together we are going to learn more of this as we prepare for the upcoming examination sessions. Bye for now.